Hello and welcome back to another AP3 video, and in today's video we'll be going over geometry questions, more specifically lines, angles, and triangles on the SAT. We'll be doing questions that are medium, easy, and hard. The question asks the following: in the figure below, line M and N are parallel. What is the value of W? Well, we're given two things, line M and N, and they're both parallel, meaning that they both never intersect and they're going the same way. They're never touching. And we're also given an angle measure of 170 and the line of T. So the good thing about parallel lines is that all angles correlate. What do I mean by that? Notice how T is the transversal, that we have an angle measure of 170. And because we have parallel lines, 170 correlates to W. So the value of W is just 170. That's how parallel lines work. So another example, if I have two lines that are parallel, and I have an angle measure of 60, that means that 60 is on this side, but also because 60 correlates to the opposite angle, it means 60 is on this side as well and this side as well, which is convenient about parallel lines or just angle rules in general. Okay, let's do a different question now. In a right triangle, the measure of one of the acute angles is 51. What is the measure in degrees of the other acute angle? Now, we're given that it's a right triangle, and in a right triangle, we have a triangle that has a 90-degree side, and the other two sides should equal up to 90. So it could be 45, 45, 30, 60, 55, 35, you name it, it adds up to 90. And we're given one of the acute angles is 51. So one of the angles and either one of the other two angles that's not 90 is 51 degrees. And we're given that we need to find the other one that is another acute angle. So all we have to do is understand that in the full triangle, the angle measure is 180, and we got to subtract it from what's given to figure out the missing acute angle. Well, we're given 51, and because in a right triangle, the right angle equals 90, we just do 51 plus 90 degrees, which gives us 141. So we use that 141 and we subtract that by 180 to figure out the missing acute angle. So 180 minus 141 degrees gives us 39. And 39 is our answer. Okay, let's go over a question that we did the first time. In the figure shown, line C intersects the parallel lines S and T. What is the value of X? Okay, so remember what we talked about, opposite angles and parallel lines. So we're given 110 and we're looking for X. We can do one of two things here. Understand that because of parallel lines, that 110 also correlates over here, and we're just looking for X. Now in a full line equals 180 degrees. So all we have to do to look for X in this example is just do 180 minus 110 to solve for X. So 180 minus 110 gives us 70. And X equals 70 degrees. Okay, let's do a harder example now. Triangles A, B, and C and D, E, F are shown above. Which of the following is equal to the ratio of BC divided by AB? Okay, let's figure out what they're asking for. They're asking for the equilibrium ratio of BC divided by AB. What am I given? I'm given two triangles, ABC and DEF. But I can't determine the side lengths or which ones are correlating to each other because they're both in different positions. So I'm going to rewrite ABC the way DEF is written. So I'm going to rewrite DEF. So F is the right triangle. D equals 58 degrees. And then I have E. So now I'm going to write ABC over here. So C is the right angle. A is the one on top, which equals 32 degrees. And B is something that we don't know so far. Okay, so I'm given that D equals 58 and A equals 32. In order to look for E and B, I have to add D and F, which equals 148, and subtract it by 180 to figure out E. So let's do that right now. So if I get 58 degrees plus 90, because of the right triangle, I get 148. So all I have to do is do 148 minus 180 to figure out E. So if I do 180 degrees minus 148, I get 32. So 32 is E. So E equals 32 angle degrees. So now let's solve for B. So I do the same thing, but with different angle measures. So I do 32 plus 90, because of C being a right triangle. I get 122. So now what I have to do is the same thing, subtracting 180 to figure out B. So 180 minus 122 gives me 58. 58 angle degrees, and that correlates to B. So B equals 58 degrees. So notice how D and B equal 58, A and E equal 32, and C and F equal 90. So those are all the angle measures that are correlating to each other. So B equals D, A equals E, and C equals F. So now all the sides are correlating to each other too, and I can figure out what AB, and BC are the equally side lengths, or which ones are they correlating to. So we're given that BC and AB is the equaling ratio of the other two sides of DEF. So let me rewrite that in green. Okay, so BC is over here, and AB is over here. Now, if I do that on the right side, I realize that DE is corresponding to the side length of AB, and DF is correlating to the side lengths of BC. So I just got to see that AB is correlating to DF, which AB is in the denominator, so DE. And then DF is correlating to BC, and BC is in the numerator. So BC divided by AB equals DF divided by DE. And our answer will be B. Okay, I'm going to do another medium question now. In the figure above, AF, BE, and CD are parallel. Points B and E lie on AC and FD respectively. If AB equals 9, BC equals 18.5, and FE equals 8.5, what is the length of ED to the nearest tenth? Before I do anything and understand what's given, I'm going to rewrite the trapezoid, or the two trapezoids actually. I'm going to line right here, and I'm going to rewrite the points that's given. CBA, and then DEF. I'm given that AB equals 9. I'm given that BC equals 18.5, and I'm given that FE equals 8.5, and we're looking for DE. Now, we're also given a lot of other information in the question. AF, BE, and CD are parallel. AB and DE lie on AC and FD, and we already went through the side lengths. So because AF, BE, and CD are parallel, the quadrilaterals of AFEB and BEDC are similar. So what does that mean by similar? What similar means basically is that all the angle measures in a shape are equal, but the side lengths are proportional. So in a square, all angles equal 90, but one's gonna be smaller, one's gonna be bigger. So if I have all side lengths that equal 1, another one can have similar angles, but can have all the side lengths equaling 4. In this case, we can see that with AB and BC. We're gonna have the same angle measures, but however, the side length of AB will be smaller than BC. So BC and AB are similar, but they're not congruent. Congruent is where all sides are equal and the angle measures are equal. But in this example, this is a similar trapezoid, not a congruent trapezoid. So because they're similar, there's going to be a ratio of when a shape increases or decreases. So we're going to do 18.5 divided by 9, which then equals DE divided by 8.5. So understand, I'm doing this to show you that the ratios of CB and AB will be equal to the ratio of ED and EF. So if I were to do 18.5 divided by 9, which you can use a calculator to make sure your calculations are correct, divided by 9, I am going to get a very huge decimal of 2 point with goddamn a lot of zeros. So if I just round it up, I'm going to get 2.06. 2.06, which then equals DE divided by 8.5. And if I multiply 2.06 by 8.5, or the huge decimal that you plug into your calculator, so 8.5, I'm going to get a decimal of 17.47. So DE equals 17.47. but we're asking for the length of ED to the nearest tenth. So around the 17.47 to the nearest tenth, which would equal 17.5. So DE or ED equals 17.5, and the only answer that gives that side length is B. Okay, let's do another question. In the figure, lines M and N are parallel. If X equals 6K plus 13 and Y equals 8K minus 29, what is the value of Z? So I'm given three things. What X equals, what Y equals, and what Z equals. Okay, so as I can see, X equals, obviously, 6K plus 13, and then Y equals 8K minus 29. But notice how both of the angles are opposites. What does that mean? Both angles are equal to each other. So I can add both equations to each other to look for K. I can do 8K minus 29, which equals 6K plus 13. And now I can solve for K. So if I subtract 6K on both sides, I'm left with 2K, which minus 29, which then equals 13. If I add 29 on both sides, I get 2K equals 42. If I do subtract 2 on both sides, let me write that over here. 42 divided by 2 on both sides, I get K equals 21. So K equals 21. So what is the value of Z? So now what I have to do is plug in 21 to equal Y or X. So I plug in 21 either Y or X to figure out the whole angle measure. So if I do 6 multiplied by 21 plus 13, I get 126 plus 13, which then equals 139. So now what I have to do is do 180 degrees minus 139 to figure out the value of Z. So 180 minus 139 equals 41, that is the angle measure of Z. So the answer here is C. Now, before you do that, you can obviously eliminate D because Z is an acute angle. It's less than 90 degrees. And it's not an obtuse because an obtuse is greater than 180 degrees. So right away, you can already cross out D. And you can cross out 8, honestly, because for an angle measure to be 3, it has to be very small. So it can't be either A or D, just looking at what Z equals on the graph. Okay, I redrew the triangle because in order for this question, there's a lot of steps to do. In a figure, AC equals DC. So let's rewrite that. AC and DC equals. So this equals this over here. So DC equals AC. And this will be very important to solve for the answer. And the figure of... in the measure of angle EBC is 45. So EBC is 45, so B is 45 degrees. And the angle measure of ACD is 104. So ACD is 104 for C. And we're looking for the value of X. Okay. First step, look at the angle measurement of C. Notice how that is a straight line. C corresponds to a straight line. And a straight line equals 180 degrees. So to look for the other angle measure of C, what I can do is do 180 minus 104 to look for the angle measure of C. So the other angle measure of C, or ACB. So if I do 180 degrees minus 104 degrees, I get 76 angle measure of 76. So C has the corresponding angle measure of 76 and ACB. So if I do ACB plus 45, I can look for another angle measure, which is right here. Which is right here. So what I can do is add 76 plus 45. So plus 45, I get, so I do 11, and then 11, so then 1 plus 7 equals 8, 8 plus 4 equals 12, so I get 121. So now what I do is do 180 minus 121 to look for the other angle measure, which is right here. So if I do 180 minus 121, I get 59. So this one right here equals 59. And because the corresponding angle is 59 equals where the green thing is, and the green thing is over here. So that equals 59. Okay, so this is the important step. We see that DC equals AC. And because both sides equal to each other, but one side doesn't equal, this is an example of an isosceles triangle. So an isosceles triangle is where two sides equal each other and one side doesn't equal each other. Therefore, because two sides equal each other, two angle degree measures should equal each other as well. So what we can do 180 minus 104, which gives us 76. So I can do is get 76 divided by 2, and then I can find an angle measure of A and D, because A and D have the same angle measure because it is an isosceles triangle, because we have two side angles that equal the same. And if I do that, I get I get 38. So D and A equals 38 angle measure in degrees. So all I have to do now is understand that 59 plus 38 gives me, so 38 plus 59 gives me 17, and then 1 plus 3 equals 4, 4 plus 5 equals 9, which equals 97. So all I have to do now to look for x is do 180 minus 97, and that will give me the value of x. So 180 minus 97, I am going to get 83. So the angle measure of x, which x equals 83 degrees. Like I said, this type of question is kind of like a puzzle where you got to go through a lot of steps in order to look for the value of x. It's easy, but you have to use every bit of information that's given to look for the value of x. It's kind of like a puzzle. Okay, before I do anything, I just rewrote the triangles and the information given on the bottom, and on the top in the left corner, I wrote the rules for similar and congruent. Remember, similar is where the sides are proportional and the angle measures are equal, and then congruent, everything's equal, the side lengths and the angle measure. And these are just abbreviations to make the statement true. Similar is side, 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 and angle, angle, and that's the abbreviations of each. For congruent, it's both side, 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 and side, angle, side, but then there's two more, angle, side, angle, and angle, angle, side. So we got to use all of that to make sure what are they asking for. And if it's congruent, we use the ones that are congruent. If it's similar, we use the rules that are similar. So in the triangles, LMN and RST, angles L and R each have 60. LN equals 10, RT equals 30. Well, that is my mistake. RT equals 30. Which additional piece of information is sufficient to prove that LMN is similar to RST? So we're using the similar rules, the SSS, SAS, and AA. So we're only given one angle so far, and we're only given one side length so far. So let's see which piece of information can make the statement true. Let's see, A equals MN and ST equals MN. So if they both equal MN, they both equal each other, right? They both equal each other. However, they're asking for a similar triangle. Because they equal each other and they're not proportional to each other, that is incorrect because they're asking for similar, not congruent. So A is incorrect. Let's try B now. MN equals 7 and ST equals 21. So are they congruent? Yes, they are. Are they proportional? Sorry, yes, they are proportional. However, the angle measure is not included between the proportional sides. Therefore, because there's no angle measure between the both sides, I can't determine if it's similar or not. So B is also incorrect. Let's try C. M and S is 70 and 60 respectively. So if M equals 70 and S equals 60, they both have angle measures, but look at it. They don't calculate the same. They have different angle measures. For it to be similar, M needs to correspond to S. So it has to be 70 for both or 60 for both. Therefore, C is also incorrect. Therefore, my only answer that can be correct is D. D is the only one that can be correct. And that is because if I do M that equals 70 and T equals 50, I can say that M and S equals 70 and N and T equal 50. And if I do 50 plus 70, so 50, if I do 50 plus 70, I get 120, and I plus 60, that gives me 180 degrees. So the only answer that can work is D. Okay, this will be the final question for today. And the question asks the following. In the figure, parallel lines P and T are intersecting by lines R and S. If A equals 43 and B equals 42, what is the value of W? So we're given that A equals 43 and that B equals 122. So I can do two things already. Write the angles that correspond to it. So 43 on this side and 122 on this side now. So now what I can do is figure out what the value of W is. So remember, a line of Q or T equals 180. So I can do 180 minus 22 to look for the angle that is next to B, which would equal, if I do 180 minus 122, I would get, so 180, minus by 122 would be 17, then 10, so I get 8, and 58, which would equal 58. So 58 over here. So now if I do 43 plus 58, I can look for the angle measure over here. So 43 plus 58 equals 11, and then 5, so that equals 101. So the angle measure missing is doing 180 minus 101, which equals 79. So this angle measure equals 79, right over here. So now let's realize a few things. Remember what we went through in the beginning of the video. Whenever we have two parallel lines, the angle measures equal each other. So 79 is correspondent here and here as well. So all I have to do now is figure out what W's, because there's two W's. But if we do 2W, that equals the whole angle measure. So all of this over here. So what I have to do is, again, do 180 minus 79 to figure out that whole angle measure, which equals 101. So now what I have to do, because this whole thing equals 101, and I'm given two W's, what I have to do is do 2W equals 101 to solve for W. So if I divide by 2 on both sides, I get W equals 101 divided by 2. And if I do my math right over here, or plug into a calculator, so 50, 100, and left with 1, that will give me a approximate amount of 50.5. So the answer for W equals 50.5. And if you multiply them together, you should get 101. That is it for today's video. Thank you for watching.